Okay, so this is the first set of notes here for a new learning target, E3.p3-b, and this is notes section 3, the theory of plate tectonics, which we kind of hammered out in that previous learning target. So B says, describe the three types of plate boundaries. They're divergent, convergent, and transform, and geographic features associated with them. For example, continental rifts and mid-ocean ridges, volcanic and island arcs, deep sea trenches, and transform faults. They kind of go with each other respectively, as you see here. Divergent would be rifts and ridges, convergent, volcanic and island arcs. You'd also get, and deep sea trenches, you'd also get mountains and things like that. And transform would be transform faults, kind of like the San Andreas Fault in California. So for this, we're going to continue watching this video and fill out these notes as we go. So I'm going to switch to PowerPoint. Okay, so section 3, the theory of plate tectonics. Number 1, define the theory of plate tectonics. The theory that the Earth's lithosphere is divided into tectonic plates that move around on top of the asthenosphere. Now, lithosphere and asthenosphere might be new terms to you instead of just crust, mantle, core. They are different. They are the mechanical properties or physical properties of Earth, and the layers are named from those properties. In other words, it's based on kind of what makes up the properties and how they act. Okay, I'm sorry, not what makes them up, but how they act. So lithosphere is very brittle, and these are our tectonic plates. And so they're moving around on this asthenosphere, which is, mantle, but it acts kind of like a fluid. It flows, and that's what these plates float on. Again, use the pause button if you need to, because I'm going to keep moving. Number 2, a place where tectonic plates touch is called a boundary. Okay, two plates are touching or meeting, that's a boundary. And the type is defined by how the tectonic plates move relative to one another. Are they coming together, moving apart, side by side, moving past each other? So 3 then says, what 3 things? We're going to pick up where I left off there. So there's 3 types of boundaries. And for number 4, it says, name each of the 3 types of boundaries, explain each boundary. In other words, what are the plates doing relative to each other? So how are they moving? And I used to have in here provide an example of a geographic feature, but you'll see on the back side of these notes that we are going to be filling in a chart where each of these features occur at different types of boundaries. So we have 3 types: convergent, divergent, and transform. Convergent means tectonic plates are colliding, they're converging. Divergent means tectonic plates are separating or diverging, going apart. And transform boundaries are where the tectonic plates slide past each other horizontally. You should be thinking about if you put your hands together, side by side with the palms down, and then move the left hand forward and the right hand backwards while they're touching. That's kind of how these transform plates are moving. Okay, sliding past each other horizontally. Again, use the pause button if you need to. So as we look at these different types of boundaries, in this diagram, it says over here on the left, convergent boundary. And it's not necessarily what we may be thinking of a convergent boundary, but this is oceanic crust to oceanic crust. And in this case, it's forming an island arc. We also have a convergent boundary where oceanic is meeting continental. And this forms a mountain chain of volcanic mountains. Now we can also have continental to continental. Actually over here on the far right, you see continental crust to continental crust, and that forms just a big mountain range. All right. We then had divergent. We can have a mid-ocean ridge, like here in the water. Okay. Or we can have a rift zone, a rift valley, where actually the boundary of a plate would be on a continent, and as they move apart, you can see water coming in here from the top. That's trying to represent that as a rift gets large enough, it eventually becomes an ocean basin. And then we have transform faults. All this one is showing us is in water. We have transform because this part of the divergent boundary should line up with the rest of it, but it doesn't because we have this fissure here, or this fault, where they've been sliding in different directions. This piece right here, under the word transform fault, is moving in a different direction than the part above it. Okay, so they're sliding past each other horizontally. So 3 types of convergent boundaries. We have 3 types of boundaries: convergent, divergent, transform. But we also have 3 types of convergent boundaries. We have continental to continental collisions. These are going to form large mountain chains, kind of like the Himalayas. We can have continental to oceanic collisions, and this is where subduction occurs. We get very intense earthquakes because of this, but we also get volcanic mountains. Then we get oceanic to oceanic collisions, and this is where we get island arcs, and again, volcanism, hotspots. Okay, so in this set of diagrams, what we're looking at here is A, B, and C. We have, oceanic to continental, and we're seeing this volcanic mountains being formed, and subduction, and you see the word, it says the word trench right there. Trenches occur as that gets, as sort of the crust gets pulled down into it. Then we have continental to continental, where it's just mountain forming. Mountain forming at its greatest. The Himalayas is our best example on Earth. This very, very tall mountain chain as India slammed into Asia and continues to do so. The Himalayas continue to get taller. We then have ocean to ocean, where this is showing us we have this little subduction zone, which forms a trench always, and we're seeing this island arc down here in C, okay, being formed because of the volcanism created by subduction. Next question says, why does oceanic crust sink beneath continental crust at convergent boundaries? Oceanic always goes beneath continental when they meet. The reason? Oceanic is more dense. That's it. Oceanic crust is more dense. The denser object is going to sink below the less dense object. In this case, the oceanic plate, piece of crust is sinking beneath the continental piece. Okay, this diagram would be a great example of subduction. Okay, because we're seeing this plate subduct down, and it's creating magma, volcanism, and this volcanic mountain chain right here. Okay. Right now, I'm going to leave the PowerPoint, and we are going to take a peek at the notes so that I can fill in our chart here. Okay. Okay, so as we look at number 7 here, we need to, it says complete the table by writing a yes or no in each box for whether the specified feature occurs at a particular boundary. So this is where we are matching up geologic or geographic features with the type of boundary. And you can see I have divergent, transform, and I have split up each of the 3 types of convergent boundaries: oceanic-oceanic, oceanic-continental, and continental-continental. All right, so trenches. Do they occur at divergent? I'm just going to do a N's and Y's for yes and no. Well, no, because divergent, they're spreading apart. A trench is a deep valley. It's a trench. When this oceanic crust goes underneath continental, it sort of sucks it down and creates this deep trench. So transform, again, no, they're sliding past each other. Oceanic, it would be a yes, because we get island arcs from this. And oceanic, there is going to be a denser piece, so one's going to dive under the other and form that trench. Oceanic continental, again, yes, oceanic's more dense than continental. And continental has to be a no. For volcanoes, divergent, those are mid-ocean ridges. And we know that volcanism occurs there because that's part of the seafloor spreading process. So we're going to say yes. Transform is a no. Oceanic to oceanic, an island arc. We have the Hawaiian Islands, and we do have a trench out in front of those as well. We also get them at oceanic continental. We get the volcanic mountain chains. This is kind of like the Cascade Mountains. You'll hear us talk about those along the west coast of the United States. And then continental, no volcanism. We're just building mountains. Hot spots. You know, we say that they can occur at divergent boundaries, but so I guess I'll put a Y there. But hotspots are just, they're hotspots. They're odd. They're oddities. They're occurring generally in the middle of a plate. The best example we have is Hawaii. There's this hotspot in the middle of the Pacific plate, and it has been continuously and very reliably producing this magma and chain of volcanic islands for a very, very, very long time. We're not quite sure why. Another well-known hotspot is Yellowstone National Park. You know, we have all those geysers and fumaroles and hot springs there for a reason, because the magma is very close to the surface. Yellowstone is actually considered a supervolcano. I'm going to go put a no for the rest of those. Oops. Mountains. Divergent, this would be a mid-ocean ridge, and I've already explained to you that that is an underwater mountain chain, really. Transform, nope, they're just sliding past each other. Oceanic to oceanic, I'm going to say yes, and this is in the form of islands. And those are volcanic mountains that have grown up from the ocean floor. We certainly have them at oceanic continental and with volcanic mountain chains. And of course, at continental, we have those very, very large mountain chains as well. Mid-ocean ridges are really only divergent. So I'll go fill a no in for the rest of those. Earthquakes. Wonder if you guessed it. That's happening at all boundaries. However, I will tell you, the most severe earthquakes, the strongest earthquakes, are happening at our subduction zones, mainly our oceanic to continental convergent boundaries, where oceanic is subducting under that continental crust. Okay? That concludes these notes.